Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 5 video from the chapter of energy, where I will solve the set 2 5 multiple choice questions based on the concepts of gravitational potential energy and kinetic energy that I discussed in part 3 video. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So this video is part of the playlist ICSE Physics for Class 8, where I primarily discuss the key concepts and formulas for numerical problem solving. So let's start part 5 video where I will solve set 2 of 5 multiple choice questions based on gravitational potential energy and kinetic energy. Okay, so the first problem says that a body weighing x kilogram force is dropped from a height of h meter above the ground. What will be the velocity of the body when it reaches a height of h by 2 meter above the ground, where g is the acceleration due to gravity in all the choices. So this is so we have to use the law of conservation of energy, that is when the body was dropped from a height of h meter and it fall down and it is falling down and it is reaching a height h by 2 meter above the ground, that is its height has decreased by h by 2 meter. So initially, let's say the body was here P, and which was at a height, let's say h. It is given the height, the body was dropped from a height of h meter. So this is h meter. The body, let's say the body was dropped from the point P, which is at the height of h meter from the ground, and it is asking what will be the velocity of the body when it reaches the height of, let's say when it reaches the point Q, this height, the height of the point Q from the ground is h by 2 meter. Now clearly, initially at the point P, the energy, if all the energy the body has was gravitational potential energy, which was so gravitational potential energy at the point P was if the mass of the body, which will be x kilogram, mgh, h is the height, so xhg joule will be the gravitational potential energy, that is the total energy the body was having when it was at a height of h meter. Now, okay, now what will be the gravitational potential energy at the point Q? It will be x. Now it is at a height h by 2, so h by 2 g, this much joule. So definitely the loss in energy, the loss in potential energy will be equal to the gain in kinetic energy of the body at the point Q. So if, let's say, the velocity of the body at the point Q, that is when it is at a height of h by 2 meter, b v q, so kinetic energy at the point Q will be half its mass, which is x, and v q square, where we are assuming that the velocity at the point Q is vq. Now this kinetic energy, this gain in kinetic energy should be equal to the loss in the potential energy of the body, which will be up minus uq. Up minus uq, as you can see, will be xh g by 2. So we have vq square by 2 is equal to xhg. So this implies that v q square is equal to x h g. This implies v q is equal to square root of x h g. So this much meter per second should be the velocity of the body when it is at a height of h by 2 meter. Oh sorry, I did a mistake. So we have half x v q square is equal to x h g by 2. In this equation x will cancel out and we will have v q square is equal to, it will be h g. So the velocity of the body when it reaches a height of h by 2 meter from the ground will be square root of hg. So the correct choice is choice D. The correct choice is choice D. Let's see the next problem. So there are two figures. In figure A, a person is holding a body of mass small m kilogram and he walked a distance of x meter parallel to the ground. Okay. In figure B, the same person pulls a rope that hangs a body of mass m kilogram over a pulley and raises the body by x meter vertically upwards. Find work done W and W2 in each situation. So if W1 is the work done in figure A and W2 be the work done in the figure B, we have to find W1 and W2. Okay. Now in figure A, please note that we have the body which is of mass small m kilogram. Now we have the person who is holding the body, and now while he is holding the body, please note that he is applying to hold the body, he is applying a force of force which is equal to the weight of the body, which will be equal to m kgf, where small m is the mass of the body. Now, so when the person is holding the body in figure A, he is applying a vertical force upwards on the body, which is equal to the weight of the body. Only then he is able to hold when the force he is applying vertically on the body must be equal to the weight of the body. Only then he is able to hold the body. Now, so the body holding the body, the person has moved x meter for x meter. So you can now, if you consider the body and the force being applied on the body and the displacement of the body, you will see that this is the body, mass is m kilogram, and there is a force being applied vertically upwards on the body by the person, which is equal to the weight of the body, which is m kgf, and the displacement is along parallel to the ground. Now, one concept you must note, always remember that we know that work done is equal to the force and the displacement, which is the displacement must be in the direction of the force. Now, if the direction of the force and the direction of the displacement are perpendicular to each other, then the work done is zero, which is exactly the case in figure A. The person is applying a force vertically upwards on the body. So on the body, a force, the force that is being applied on the body is vertically upwards, and the body is moving parallel to the ground. So the displacement, so this is the force, so the displacement, and this way is the displacement. So the direction of the displacement and the direction of the force, they are perpendicular to each other. So no work is done. So definitely we must have W1 should be equal to 0. Now at this stage we can clearly reject choice A and choice B. Now let's see what will be the work done in figure B. So in figure B, the person is pulling the rope, and the rope is the rope is over a pulley. So this is the pulley, let's say, and at the other end of the rope there is a mass, there is a body of a small m kilogram is hanging from the other end of the rope. Now when the person is pulling the rope, he is applying some force. Let's say he is applying some force. Let's say this force, the person is applying a force, let's say F, and this force is and since he is pulling the rope, there is a tension in the rope. The tension in the rope will be in the upward direction, and this tension will also be F. And this tension in the rope, which is acting upwards, is actually pulling the body of the same mass, that is small m kilogram, upwards. So the force F the force F is acting vertically upwards, and the displacement of the body is also upwards. So for figure B, definitely the work done is equal to also note that since the weight of the body is acting vertically downwards, W. Now the person since the person is able to pull the rope and pull the weight up, it means that he is applying a force, minimum force, which is equal to the weight of the body. So the force applied, or the tension which is the tension in the rope which is pulling the weight upward vertically upwards, that tension or force is also equal to the weight of the body. So the work done will be force W2, which is the work done by the person in figure B, will be the force, which is the force multiplied by the distance. The force will be the weight will be equal to the weight of the body, which is small m kgf, and we have multiplied by the body was vertically lifted up by x meter, so x meter. So definitely W2 is not equals to 0. Some work is done by the person in figure B. So the work done will be, now 1 kgf is 1 kgf is we know now m kilogram force, m kilogram force is also equal to mg, where g is the acceleration due to gravity near the surface. So this will be mg x this much joule. So the work done by the person in figure B will be mgx joule. Hence the correct choice will be choice D. Let's see the next problem. A ball is dropped from a height of h meter. If the energy of the ball reduced by 40% after striking the ground, how much high can the ball bounce back? Now, so when let's say the ball is at the height, at the point A, which is at a height capital H meter from the ground. So the ball is dropped from the point A. Now when it reaches the point B on the ground, let's say this is the point B is on the ground, then at point B it will lose all the gravitational potential energy which was at the point A. The energy of the ball was mgh. Let's say let mass of the ball P, let's say m, m kilogram. Okay. Now, quite obviously, at the point B, the ball will lose all its gravitational potential energy, and all the gravitational potential energy which the ball was having at the point A will be transformed to kinetic energy at the point B. So we will have the potential energy at the point A will be equal to the kinetic energy. U denotes potential energy and K denotes kinetic energy. So the kinetic energy at the point B will be equal to the potential energy at the point A. Now, if after the ball hits the ground, if there is no energy loss, then since the ball is having a velocity, what will be the velocity of the ball at the point B? So what is UA? UA is that is the gravitational potential energy of the ball when it was at a height h meter was mgh, where I am considering the mass of the ball to be m kilogram, this much joule, and let's say the velocity. Now we need not find the velocity of the ball at the point B. That will not be required to solve this problem. But anyway, just for the discussion, I am computing I am finding the velocity of the ball at the point B. So let's say if the velocity of the ball when it reaches the ground at the point B be Vb, then Kb, that is the kinetic energy of the ball at the point B, will be half mvb square. We know the kinetic energy of a body having which is in motion with the velocity v is half mv square. Now this must be equal to mgh. So this implies that vb square is equal to 2gh. This implies vb will be equal to square root of 2gh, where g is the acceleration due to gravity, whose value is 10 meter per second square or 9.8 meter per second square. Now in this problem, if there was no after hitting the when the ball hits the ground at the point B, if there is no energy loss, then what will happen? The ball at the point B, all the energy the ball is having is kinetic energy, which is equal to half mv square, half mvb square, which is also equal to mgh. The ball will again bounce back. And will reach the height of h meter, because at the point B, all the energy the ball is having is the kinetic energy, which is half mvb square. Now it will bounce back with the same velocity Vb, but since due to the gravitational pull, its velocity will slow down, so it will lose its kinetic energy, and it will reach the point A, where it will lose all its kinetic energy, and it will again have the gravitational potential energy, which is mgh. But in this problem it is given that the ball is losing 40% of the energy when it hits the ground at the point B. So quite obviously, what will happen? Quite obviously, now since it has lost some energy, 40% of the energy, it will not again rise to the point A. It will rise to a height which will be less than capital H meter. So it will rise to a height which will be less than capital H meter. Let's say when it is bouncing back, let's say it rises to a height C. It rises to the point C, where the height of the point C from the ground is small h meter. small h meter. So after the ball hits the ground at the point B, let's say it bounces back and reaches reaches a height of and reaches the point C, maximum height of point C, which is at a height small h meter. So now, from the law of conservation of energy, I must have after hitting the point B in the ground, what will be its energy, since it has lost 40% of the energy. So so we can say that the energy, the total energy at the point B is also equal to mgh. Now, but after hitting the ground, it will lose its energy is reduced by 40%, which means energy reduced is equal to 40% of EB, where EB is the energy of the ball at the point B, which is equal to mgh. Now 40% of the energy at the point B, 40% of the energy at the point B is lost. Now what is the 40% of the energy? This is 40% means 40 by 100 multiplied by EB, which is equal to twice EB by 5, which is equal to EB is 2 mgh by 5. This much energy is lost. So what will be the energy after 40% of the energy is lost? So after loss of energy, after loss of 40% energy, energy remaining will be equal to original energy was mgh and the energy loss was 2 by 5 mgh. So this much energy, which is 3 by 5 mgh, is now the energy of the ball at the point B after it loses the 40% energy. So now if the ball bounces back to a height of small h meter, then obviously we must have at the point C, the gravitational potential energy is m small h g. This energy should be equal to the energy of the ball at the point B after it lost 40% energy, that is 3 by 5 m g h. So from here we can cancel out m and g, and we get small h is equal to 3 by 5 of capital H. So after the ball loses 40% of the energy, when it hits the ground, it will bounce back to a height of 3 by 5 h meter. So the correct choice is choice C. Let's see the next problem. A train of mass m kilogram is moving at a constant speed of v meter per second on a track which is at a height of h meter above the ground. What is the work done in bringing the train to rest? Okay. So so the train is moving, the train of mass m kilogram is moving at a constant speed of v meter per second. So it is having a kinetic energy. So the kinetic energy of the train is moving on a track which is at a height of h meter, that is fine, but the kinetic energy of the train will be half m V square. This much joule is the kinetic energy of the train. Now if this train, if so what will be the work done if, but definitely, quite obviously, some force has to be applied on this train to so that to stop the train or to put the train at rest, and that force, so whatever work that force is doing, it will be definitely equal to the kinetic energy of the train when it was moving at a speed of v meter per second square, v meter per second, because the total because the train lost because the train was having an energy of half mv square. Now so let's say, so this is the train, let's say this is the train, it was, so definitely to stop the train, it is, let's say it is moving in this direction with the velocity v meter per second. So definitely to stop this train, a force has to be applied, in the opposite direction, that is opposite to the direction of the motion of opposite to the direction of motion of the train, then only the train will stop. So in this case, the direction of the force, obviously once the force was applied, the train will move to some distance and then it will stop. So what will be, let's say a force was applied, and let's say after moving a distance of, let's say this is d meter, after moving a distance of d meter, the train stops. So we can say that the work done by the force to stop the train will be the force applied. We don't know what force, but the force applied multiplied by we can say the distance, multiplied by the displacement of the train. Now please note that the direction of the force is opposite to the direction of the displacement of the train. So so a negative work has been done on the train to put the train to rest, and that negative and that work done the magnitude of the work done is definitely equal to the kinetic energy of the train, because the train lost an energy of half mv square, and so where did from the fact that law of conservation of energy is never created or energy is never destroyed. So we know that energy is only transformed from one form to another. So the train lost an energy of half mv square. So now the force that was applied, so clearly the force that was stopped the train has to be applied opposite to the direction of the train, opposite to the direction of motion of the train. And the work done by that force has to be equal, the magnitude of the work done by that force has to be equal to the loss in the kinetic, the loss in energy of the train. What is the energy lost? The energy lost by the train is half mv square, because initially it was moving with a speed of V meter per second. So it was having a kinetic energy which is half mv square, and finally the velocity of the train was 0. So I can say that the work done is basically minus half. The work done to put the train to rest is minus half m v square, this much joule, because the force that was the force that has to be applied on the train to put the train is in motion, and if so any force that will put the train to rest, that force has to be applied opposite to the direction of motion of the train. So if the direction of the force is opposite to the direction of the displacement, then a negative work is done. Obviously, the amount of the magnitude of the work done should be equal to the energy lost by the train, which is half mv square. That's why the work done should be minus half mv square. I think in the given choices, the choice D should be minus mv square by 2, because in this case, when a train in motion is put to when a train is in motion is moving with the velocity, and if it is and some applying some force, if the train is put to rest, then a negative work is said to be done on the train. Now, why? One thing to note is that the train is running on a track which is at a height of h meter. Now, obviously, the train is having a gravitational potential energy of mhg, but when the train was put to rest, it was still at a height of h meter. So there was no loss in the gravitational potential energy of the train. So no work was done, no energy or no work was done. So the fact that the train was running on a track which is at a height of h meter has nothing to do with the work done in putting the train to rest. So the information that the track is at a height of h meter is just to confuse the student. So the correct choice is D, but it should be minus half mv square joule. Okay, let's see the next problem. Two bodies A and B are dropped from heights of capital H and 3h respectively. If VA and VB be their velocities on reaching the ground, then the value of the ratio VA is to VB is. Two bodies A and B are their masses are not given. Okay, two bodies A and B are dropped from heights of h and 3h respectively. Let's say this is the body A, which is at a height h, and there is another body B, which is at a height 3h. Okay, so if VA and VB be their velocities on reaching the ground, then the ratio of VA is to VB is. So we know that when for the body A, when it will reach the ground, it will lose all the gravitational potential energy which when it was at a height of h, which is, let's say the mass of the body A is ma, and let's say the mass of the body B be mb. So let's say UA is the gravitational potential energy of the body A when it was at a height h. So this will be ma h g. Also, similarly for the body B, UB, let's say UB with the gravitational potential energy of the body B when it was at a height 3h. So it will be mb 3h g, which is 3 mb h g. G is the acceleration due to gravity. Now, when the body A reaches the ground, it loses all the gravitational potential energy, which was ma hg, and it will have and the gravitational potential energy will be converted to completely converted to kinetic energy. So if Va is the velocity of the body when it reaches the ground, the kinetic energy, let's say the body A reaches the ground at the point P, and the body B when it reaches the ground, let's say at the point Q. So the kinetic energy at the point P of the body A will be half m a va square, because we know the kinetic energy of a body of mass m having a velocity v is half mv square. So it is given that va is the velocity of the body A when it reaches the ground. So the kinetic energy of the body A when it reaches the ground at the point P, which I am denoting by Kp, will be equal to half ma va square. Okay. Now this kinetic energy should be equal to the gravitational potential energy of the body A when it was at a height of h. So this should be equal to ma h g. So we have ma va square by 2 is equal to ma h g. From here we can find that ma cancels out, and we can see va will be equal to square root of 2 capital H g. Similarly, for the body B, let's say Kq is the kinetic energy of the body B when it reaches the ground. It will be half m b vb square. This should be equal to the gravitational potential energy when the body B was at height 3h. So this should be mb 3 mbh g. So we have mb vb square by 2 is equal to 3 mbh g. This implies mb cancels out from both sides, and we have vb square is equal to 6 h g. This implies vb will be equal to square root of 6 h g. My laptop is discharging. Okay, so we have vb is equal to square root of 6 hg. So now the problem has asked the ratio va is to vb. So we have va divided by vb is equal to square root of 2 hg divided by square root of 6 hg. This is equal to square root of 2 divided by square root of 6. This is equal to square root of 2 by 6, which is equal to square root of 1 by 3, which is equal to 1 by square root of 3. So this implies va is to vb should be equal to 1 is to square root of 3. So the correct choice is choice B. So with this it comes to an end in solving set 2 of 5 multiple choice questions based on the gravitational potential energy and kinetic energy and transformation between them. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Now if you have any doubt regarding solving any of these problems, any steps or any concept that I have applied, then please feel free to let me know in the comment section. I will do my best to help you out. In the next video, I will discuss about the power. So please stay tuned for the upcoming videos to come soon. I'm ending the videos here. Thanks for watching, and until the next video, take care and bye.